And so now you're going to take what you've learned and you're going to use it to create good arguments, or to figure out whether an argument is a good argument or an invalid argument. Okay, an argument consists of two parts: premises and conclusion. So you have a fill in the blank there, and then you already have the two bullets on your handout, so you're writing in the words premises and conclusion. It's as if you're in a court of law, and if you're presenting an argument to the jury, your premises would be your evidence. Okay, you're presenting your evidence, and so based on the evidence, can you agree to that conclusion? Does that conclusion work? Okay, so that's what we're looking at today. So premise 1, I study for 5 hours or I fail. Premise 2, I did not study for 5 hours. Okay, so here's our evidence, and those are the sentences that you're writing down next to premise 1 and premise 2. And so my conclusion, therefore I failed. So this is an example of an argument. You present things that you know to be fact. You assume that those first two things are fact, and then you determine whether the conclusion does follow given those premises. So we're going to revisit this argument in a minute. So you'll see those sentences again. An argument is valid if the conclusion is true whenever the premises are assumed to be true. An argument that is not valid is said to be an invalid argument, also called a fallacy. Okay, other words you may have heard from the creative thinking class. Okay, so you want your arguments to be valid. You want to make sure that you're able to structure these things in a way that, you know, are good arguments. You know that you'll win more debates, okay, if you have good arguments. As a child, you would argue with your parents about stuff, and you'd say, yeah, I should get this because, you know, I'm old enough. Okay, not a valid argument. So, you know, your parents were able to say, no, that's not quite right. Okay, you have to present good arguments in order to win those things. So here's another argument. If I get an A on the final, I will pass the course. And notice off to the left, I've translated that symbolically. And so you have the symbols, I think. Do you have the if P then Q? So right next to that symbol, if P then Q, write that sentence. If I get an A on the final, I will pass the course. So the next symbol is a P. I got an A on the final. And then the third statement there is Q. I will pass the course. Okay, so on the left with the symbols, it almost looks like an arithmetic problem. So you have one plus another gives you a result. And that's pretty much what we're looking at. The first two things are the premises, then you have this horizontal line. And then this triangular dot pattern means the words thus or therefore and so on. That is actually a very common thing in mathematics, is that if you're trying to create a proof and you're proving something to be true, then the common thing is at the end to go dot, 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 this little triangular pattern, and show your answer. And so that triangular pattern means the words thus or therefore, saying, here's my conclusion. Okay? All right, so we're going to actually prove whether this is a valid argument or not. But the first thing I have to do to prove it is to first translate the symbols into one big compound statement. And so the way I do that is I want to take the argument and say, so here's what I really have. If I get an A on the final, I will pass the course, and I got an A on the final. So those are my premises. Here's my first premise and my second premise. Therefore, I will pass the course. So therefore, my conclusion. So notice at the very bottom, I've translated the whole thing into one compound statement. And what I did was I put the first premise and the second premise. Now notice the first premise had more than one letter in it, so I put that in its own parentheses. So premise 1 and premise 2, and I put all the premises inside brackets. Therefore, well, we're saying if the premises are true, then the conclusion is true. So that's where my arrow comes from, because therefore is another way of saying if then. And then it leads to my conclusion. So if anything, you have my premises lead to my conclusion, arrow to my conclusion. And now, to tell whether this is a valid argument or not, we're going to do a truth table. So notice you have a truth table on your handout that's already been partially filled in. Okay, the last column is the only thing that has not been filled in, so the last column would be for this entire compound statement here. But on the truth table, I've broken it down. You've got a P and a Q, and there's only 2 letters here, so that's why there's 4 rows. Then you have to do the innermost parentheses, the if P, then Q. Then you have to do the bracket, the and between the premises, and then you have to do the entire if then. So go ahead and fill in your truth table. So valid arguments are tautologies. That is, they are always true. So the question is, did you end up with a tautology? Yes, you should have. What does it mean when it's a tautology? All truths in the last column. Okay, so here was our truth table. And this is what you should have gotten there in your truth table. And so notice that the last column is all truths, therefore this argument is valid. So you can make a note, this is valid. The inner, you always, it's just like order of operations. So you want to do the innermost parentheses first. So that's why we did the if P then Q. And then we're working our way out of that parentheses, and so that inside that bracket, and then we can move on to that conclusion. Okay, so let's summarize what we did to make this happen. The first thing we did was we used a letter to represent each simple statement in the argument. We had P and Q. The second thing we did was we expressed the premises and the conclusion symbolically. That was actually, these 2 things were actually already done for you. So I put that, so the second part is that arithmetic-looking symbol problem. If the argument contains n premises, write the symbolic conditional statement of the form here. So basically what this is saying is that even if there is more than 2 premises, you're going to take premise 1 and premise 2 and premise 3 until you run out of premises. And you're going to put brackets around all of your premises. Then you'll have an arrow that leads to your conclusion. Now, if your conclusion has more than 1 letter in it, you have to also put your conclusion in parentheses as well. So any statements that have more than 1 letter, you need parentheses around them. Okay, so once you've done this, then you need to construct a truth table for the conditional statement in step 3. And then if the final column of truth tables has all truths, the conditional statement is a tautology and the argument is valid. If the final column does not have all truths, the conditional statement is not a tautology and the argument is valid. What I'd like you to do is in that last place where you put tautology, go ahead and underline the words not a also. So when you look back at your notes, you can remember tautology, valid, not a tautology, invalid. So if there is even 1 false that appears in the final column, it's an invalid argument. That would denote a special case where that statement isn't true. Okay, so that underlined part is the most important part to remember. Tautology, valid, not a tautology, invalid. I asked you guys to underline. Yeah, not a. Okay, so here's the the first argument that I gave you guys. I study for 5 hours or I fail. I did not study for 5 hours, therefore I failed. And so I've already identified your P and your Q. And so what I'd like you to do is I gave you a little bit of space in the margin there off to the left. Go ahead and off to the left, translate each of these symbols symbolically, or each of these statements symbolically. So off to the left, you're doing like that vertical arithmetic problem. Okay, in the first statement, what's the key word? Or. And so you should have had P or Q. In the second statement, okay, the key word is not, so you have not P. And then your bar and your triangular dots there. Q. Okay, so we just translated each thing individually. So we identified our two premises symbolically and our conclusion symbolically. Okay, so now you want to convert this to one compound statement using the brackets and so on. So you have to take the first premise. Does it have more than one letter? Yes, so put it in parentheses. And then you have another premise, so what should go in between the premises? And, good. Those are our only premises, so what do we put around the premises? Brackets. And then we need therefore, which is the arrow leading to our Q, our conclusion. And the conclusion is just one letter, so we don't need parentheses there. So this is what you're making a truth table for. So now you make the truth table. Okay, so you have two different letters in this truth table, P and Q. So you start out with your standard pattern there. Then I need to do what next? Okay, you have a choice actually for what's next. You can do the not P. Yeah, you don't. In this case, you could do the not P because it won't affect anything. Notice I made my column a little bit bigger, so I like to do what's inside the parentheses next. Okay, so an or is only false when they're both false. Good. So true, 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 false. Okay, so now we have to do our not P. We don't have a choice there. And so that would be false, false, true, true. Now we're going to do what's inside the brackets. And so this is an and. So an and is only true when they're both true. Okay, so I'm just looking at the two premises column, the P or Q and the not P, these two. So we have false, false, true, false. And then in the last column goes the entire compound statement. And so this is an if-then that we're trying to prove now. Right, so this entire bracket is our if, and the Q is our then. So we're looking at this column for our if, and Q for our then. And an if-then is only false when if true, then false. Okay, so where it's if false, I don't even have to worry about it because it's already broken the pattern. So that's true and that's true. If true, then true, I'm okay. So that's true. And then if false, I already know it's going to be true. So I got all trues, so therefore this is valid. 170, you have this chart right here. And this chart gives you 4 common valid arguments and 4 common invalid arguments. So if you wish, you can refer to this and say, so let's see, that last one was actually the disjunctive reasoning. See, this is how it translated P or Q, not P, therefore Q. So I could have said, oh, that's disjunctive reasoning. I know it's valid, and I could have skipped the truth table. Okay? So that's so you can use this because they've already been done for you. Yeah. Well, you can put whatever you want on your note card. So whatever you want. Now, if it's a show your work type problem, then you're going to need to say, oh, disjunctive reasoning if you're not going to show me a truth table. So unless it specifically says show a truth table. So if it specifically tells you to use truth table, you got to use truth table. All right, but then these are always going to be invalid. So if your pattern ends up being one of these, then you already know, oh, I don't need to do a truth table. That's invalid. I can skip that part. Okay? So use those to help you out if you need to.
What size of the card you can bring?
4 by 6. Which is about that, right? Okay, so consider that. Yeah, it's a photograph. Yeah, 4 by 6. 4 by 6 and you know, because of that, I specifically put 4-inch by 6-inch note card on the information. Okay, so there will be times when it asks you to come up with what the best conclusion would be. So you want to look for, you know, that chart could be handy in those situations too.